So here we're going to play with polynomial expressions. So polynomial is a series of x's and a power with some multiple that's constant, and we have addition and subtraction with those. Let's look at a subtraction. The main thing about polynomials and addition and subtraction is the idea of like terms, same variable but same power. Subtraction is a little more complicated in that you have to distribute the subtraction to the second polynomial. So the first one stays the same. And then I'm subtracting the second, so we treat that subtracting the negative is going to be a plus x to the fifth. And then this will be a minus 10x squared, and then a plus 9. And we look for the like terms. So there's a fifth power here and here, so we have -3 of them and we have 8 of them. So altogether, we're going to have 5 of those x to the fifths. And let's see, are there any squares? One there, one there. So we have 2 of them here, -10 of them there. So altogether, we're going to end up with -8x squares. For 3x, there's no other terms with an x in it over here, so it's just all by itself. So we'll have a plus 3x. And similarly, the 9 is all by itself, so we'll have a plus 9. So that would be the subtraction of these two polynomials. So sometimes we had like terms, sometimes we didn't. We put them all together. That's that. Let's try another polynomial expression. So here we have a multiplication of a monomial by a trinomial, and it's just the idea of distribution. So this monomial here needs to be multiplied into each term of this polynomial. So 2x squared times 4x, 2 times 2 is, 2 times 4 is 8. And then x squared times x squared is going to give us x to the 4th. Remember, when you multiply two powers with the same base, you add the exponents. Minus 2 times 1 is 2, x squared times x is x cubed. And then finally 2 times 4 is 8, and there's no x's there, so it's just going to be an x squared. So that would be the result of multiplying. And as far as simplifying goes, I simplified as I went by saying 2x squared times 4x squared is 8x to the 4th. So I multiplied and simplified at the same time. Here the multiplication is a little more complicated because I have a sum here, so that's a binomial instead of just a simple monomial. So we have a double distribution. And the bottom line is each term in one polynomial has to be multiplied by each term in the other. Since there's 2 terms here and 2 terms there, there's going to be 4 multiplications. So starting with the x, we'll have to multiply it through. So x times 2x is 2x squared. X times -5 is -5x. And then we distribute the 1. 1 times 2x and 1 times -5. So 1 times 2x is plus 2x, and 1 times -5 is -5. Sometimes you end up with like terms after multiplying a couple of polynomials. In this case, we have a pair in the middle. -5x's plus 2x's leaves me with -3x's. And the other terms just get carried along. And boom, we're done. That's the product of those two monomials division. There's a couple of different ways to view this. You could view it as the result of adding some fractions. So fraction addition and subtraction needs a common denominator. So consider -6x to the 4th over 3x squared minus 9x cubed over 3x squared plus 3x squared over 3x squared. If we had started with this blue expression, since we have a common denominator, we keep the denominator and combine the numerators. So I basically unadded this fraction right here, which is going to let me reduce. So I just look at one part at a time. So looking at the first fraction I created here, 3 goes into -6, -2 times. and then x squared goes into x to the fourth, leaving x squared behind. The rule for dividing powers with the same base is subtract the exponents. Another way to think about it is there's 4 x's multiplied in the top, 2 x's in the bottom, and so pair cancels out. Here we have 3 goes into 9 3 times, x squared goes into x cubed x times. And here I have basically a number divided by itself, which is just a +1. So that should be the answer right there of that division. I'm also going to look at this as long division, which we would have to do if this was a binomial or a trinomial. So this fraction version only works if it's a monomial. So if I tried a different version of this, I would use long division, and I would say 3x squared goes into negative 6x to the fourth minus 9x cubed plus 3x squared how many times? So I would ask, what would I multiply by 3x squared to get negative 6x to the fourth? Well, let's see. I would have to multiply by a 2, and it would have to be negative, and I need another x squared. So carrying out that multiplication gives me negative 6x to the fourth, so I match that. And with division, we then subtract. And in algebra, we subtract by adding the opposite. So that's going to bring me a 0 here, and I bring down the next term. And now I get negative 9x cubed. What would you multiply by 3x squared to get negative 9x cubed? Well, I would have to multiply by a negative 3, and I want the power to raise by 1, so I multiply by an x. Negative 3x times 3x squared is negative 9x cubed. We engineered that to happen. Then we subtract by adding the opposite. Get a 0. And bring down the next term. 3x squared. What would you multiply by 3x squared to get 3x squared? Well, I think I would multiply by a 1, a positive 1. 1 times 3x squared is 3x squared. Add the opposite, and I get a 0 remainder. And so that must be the answer, which matches what I get the other way. So you have a choice. You can either do with a monomial, break it up into fractions, or you could use long division. If this was binomial down here, you would have to use long division. That's it for now. Take care. Do good math. See you in the future.